Hello there, folks. In this quick video, we're going to design an E3 simulator. So a couple of videos I already done on E3 using a real E3 block, but in this case, we're going to build a device that mimics an E3, which allows us to force some inputs, see if outputs work, and force some analog input signals and see if we get analog outputs. If we don't have the real E3 I/O in front of us, this is a nice tool to use to simulate. So what I mean is if I had the real E3 here, like the one I've been playing with, and if I wanted to turn on an input, I'd have to go put a wire across something or wire something to an analog signal and see it come on. And that requires a lot of work, particularly if you're trying to do some timing things and other stuff. You got to really do a lot of work. So in this case, we're going to build a simulator that mimics an E3IO, and we can use a red line, another device, to simulate. So in this case, I'm going to use a DA30 for this application. And on my DA30, I got a database right here with the DA30. And I want you to notice that over in data tags here, I've got a folder here called E3IO. And then I went through and I created some other tags in here. I've put a folder called digital input. And then I got a bunch of flag tags for my digital inputs here that I'm simulating. Notice that they're all blue. They're not connected to anything. They're all internal tags right now. And if I happen to go down a little further, I'll collapse that tree. And if I go, I got digital outputs. I got a folder here. I got some DOs. Remember one thing here, these DOs, the name of these are actually D0_1. If you call it DO_1, the software sees that as a do function in C, and that doesn't quite work out as well. So you actually have to call it D0_1 or whatever for a digital output here. And then if I expand my analog input, I've got some X's, which means these are numeric tag. When you hit the pull down here, these are a numeric tag versus a flag tag, which is a Boolean. So these are all X's, AI 1 through 8 in this case. Again, they're all blue. They're not mapped to anything. And if I expand my analog outputs folder, I've got some other ones, AO1 through AO4, because the block I'm trying to simulate has 4 analog outputs as well. So if I go over here to communications in this case, and on protocol 1 or 2, I don't know what happened to protocol 1 here. Let me try something here. I have my protocol 1. I don't know. It's down here. That's weird. Can't really move it. Anyway, so I'll click on whatever protocol. It doesn't matter. But anyway, I click on a protocol here, and I'll hit the pick button. And I'm going to choose for this one Modbus because the E3 communicates on Modbus. So I'm going to choose E3, and I'm going to make my DA30. Remember, I'm using a DA30 here to simulate the E3. So I'm going to make it a Modbus slave or a server device. I'll click OK. And then over here, I'm going to change the name of this to E3 underscore. It's actually mimicking a mix 20884 station. So I'll do that. This is the slave driver. A couple things you'll notice. You don't see an IP address here. That's because this driver is actually going to use the IP address of the Ethernet port here in device configuration. This is Crimson 3.2, so it looks a little different. But so the IP address of my slave device is going to be 192.168.1.22. So back here at communications, I click on this E3. I'm going to add a gateway block here. I'll click on the block. And this is going to be my discrete input data. So if I hit the pick button here, you have these registers. Give me a second here. Let me go back to Crimson 3.1, for instance. I'm using Crimson 3.1 because if you pick the particular product that you're mimicking, it doesn't really, they're all the same, but if you pick that product, that's the one I'm mimicking. When I go to I/O channels over here on the left, if I click on I/O channels, it gives you kind of an overall layout of the stuff. And it's not very clear, but these are the discrete input registers. These are the digital coil output registers. These are the analog input registers. And these are the holding registers down here. So if I slide all the way to the top, here's my discrete inputs here. I'm going to use the first 8 on this particular guy. So if I go back to my database we're building here, I'm going to click on digital inputs. These are known in the Modbus world as the 1000 series because here's a 1. Someday we'll put a plus here. These are the 1000s. It's a bit. That's correct. I'll click OK. And I'm going to do 8 because I actually have, if you look on the right side, I have 8 digital inputs here. So I'm going to change the block size from 0 to 8. Notice when I do that, it changes dramatically. I get 8 registers over here. If I click on this one, you see Crimson normally goes here to devices, but I'm going to go to data tags, and I'm going to grab these and drag them over here like this. You can also double click on them. So if I put my cursor here, and this is number 4, boom, boom, then you go down the list like this. Either way works. The important thing you're looking at here is you want to focus on this arrow. These digital inputs, if they go on, I want to put them in these registers to mimic digital inputs. So up here where it says block 1, let's go ahead and rename this, for instance, because it is digital inputs. So I'll call it digital inputs. Let me click up here on the E3 again. I'm going to add another gateway block right there. Click on this guy. This is going to be my digital output, so I might as well go ahead and name it right now. All right, and I'll hit the pick button. Now these are all going to be mapped to the coils. These are the 0,000 registers, if you call them the 0,000. These are the digital coils. I'll click OK, and we have over here on the right side, we have 8 digital outputs we'll use. So we'll change the block size here from 0 to 8. Now I get 8 individual registers here. So if I click on the first one, I'm going to go over here. I'm going to double click on my digital output number here. Again, you can drag them over or you can double click. Either way works. The important thing is you want to put them here in the order. But here's where things are a little different. This guy, when I change these, I want him to change these outputs on my simulator. So if I click on the register, the gateway block above here, right here where it says direction, I'm going to change this to be device to Crimson. So when these are written to from the Modbus client or master, it's going to write to these guys here. Okay, that's perfect. Notice the color red, whatever. Let me go up here and click on E3 here again. I'll do add gateway block again, and I'm going to call this one my analog inputs. There we go. And I'll hit the pick button here, and these are going to go to my input registers. These are known in the Modbus world as the 3000 series registers. Everything's a word here, so I'll click OK. We have on the right side, looks like 8 analog channels we're simulating, so I'll change this to 8 here. Again, notice the tree expands. Notice the register number, 3001. If I expand, these are the zeros. Expand these are the 1000 series. So just point that out to you again. Anyway, if I click on this first one, I'm going to double click on each one of these. And that's going to add them to the left side here. Again, you want to pay attention to the arrow. It's real small, but there's an arrow going from the right side to the left side. So it's going to put these in there, those locations. Perfect. Let me go ahead and click up here on the E3 again. Let me add one more gateway block. Boom, right here. And I'm going to call this one my analog outputs. All right. And these are going to map to the holding registers. These have got to be writable registers, so these are going to go to the holding registers. So I'll click the holding, not these are an Enron version. We're using this here. Click OK. And we have 4, I believe. Let me expand this tree. We have 4 analog outputs here. So I'm going to change the block size from 0 to 4. There's my 4 registers. I'll click on each one of these, and I'll double click here. Boom, 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 like this. And this puts them in there. Now, these are a little different. Just like the digital outputs, I need these here to write to these registers. So I'm going to click on the block analog outputs and change the direction device to Crimson. So that should work there. Perfect. All right. Let me go over here to display pages. We want to see this in our simulator. So on my display page, I'm going to go to the left side and I'll drag my digital inputs out here like this. Make this guy be a little bigger. I'll drag my digital outputs here like this. I'll drag this guy to be a little bit bigger like that. I'll drag my analog inputs. Make that box be bigger. And I'll drag my analog outputs in here, like so. So these are my inputs. This is my digital inputs. This is my digital outputs, my analog inputs, and my analog outputs. Now, this is going to sound weird, but the stuff here that's an input, we have to be able to change to mimic. So I'm going to click on this guy. Remember this little trick. If you click anywhere else, you lose focus. And then if you click on it one time, this little box here turns on the data entry. And you can go through that manually, all of them, or you can cheat and highlight or oscillate or pick these other 7 tags, right click and do copy from and choose all, copy all formatting, Notice it's got a trailing X. It's asking you who do you want to copy from. This one right here. Boom. That does that. And then all of my analog inputs, I need to make them data entry as well. So I'll just I'll go ahead and highlight all of them. Right click, copy from, all formatting. Oops, I think I clicked on the wrong one. Let me right click again, copy from, choose all formatting, and I'll just click on any of these. Doesn't matter which one. All of them. Perfect. All right. Now I'm using the DA30 for this. So let me go over here to my web server. And on the DA30, I'm going to use port 80 for this. So normally it's set up as 443. I'll do port 80 here, like so. And then I'll click the features tab. And on the features tab, I want to make sure I have remote control enabled, which I do. And then I prefer the bare display scaled mode for my web server. I just love that. So let me save that. And let me go ahead and download this to my screen or my DA30. I think I'm using the USB. That's correct. So let's go ahead and download it. Maybe. Okay. So it downloaded it. So now I've got that downloaded to the unit. Now, in the previous video, I was using my a Geo7 simulator. So in this case, if I go to my Geo7 database, go over here to communications, I've got this thing here. There's the IP address of the Geo7 that's going to be a Modbus master talking to this unit. So that's fine there. I'm using the emulator with this guy. Notice the emulator button here is turned on. Before I download to that, let me go over here and let me open up the web page address. Notice the IP address. This is the IP address of the DA30. So if I click remote view, I can see all my stuff here. That looks fine to me. Let me go back to my emulator here. Let me go ahead and emulate, download to my Graphite 7-inch here. And if I go to the E3 Modbus page right here, this is the values that this guy is being a Modbus master talking to the E3. So if I go back to the web page here, and if I turn on some of these inputs, let's turn on this guy, this guy, this guy, and this guy. So I turned on all of the odd inputs, 1, 3, 5, and 7. So if I go back to my emulator here and look, 1, 3, 5, and 7 are on. Hey, that's pretty sweet. What if I go back to my E3 simulator and I simulate an analog value, for instance? Now, these guys are limited to 32,767 from the range of 0 to, anyway. So if I put in here, for instance, 16,000, now it's putting that out here. If I go back to this guy, there's that signal that it's reading in. What about on my Modbus master? If I want to turn on, say, my outputs that are my even number outputs, like so. If I go back to the web page, look, digital output 2, 4, 6, and 8 are on. That's perfect. And what if I want to turn on a analog output value here? Let's say I put in 12,000 here, for instance. There it is. And if I go back to my, there's that value there. Sweet. So that works perfectly well. Let's take that one step further. And instead of looking at the raw numbers, which is 0 to 32,767, let's say that our analog values, we want it to show a 4 to 20 milliamp for those readings, if you will. So my easy way to do this is, let's think here. If I go to this guy here, click on AI1 here, and down here where it says do not scale, let's choose, let's think here. Let's do this. Let's scale to integer and let's put 0 to 32,767 here. Okay. But we want to display from 400 to 2,000. Oops, that's supposed to be 2,000. Okay. Now I'm going to go to the Format tab. And on the Format tab, I'm going to hit the pick button. I'm going to choose Numeric. And the reason I chose Numeric is because down here, I'm going to change this digits before is 2, digits after is 2. And down here for units, I'll put little m, big A. Okay. So now in theory, I've put a 400 to 2000, which is 4.00 to 220.00. That number should show up. Let me go over here to display pages. Okay, so once I click it updated here, let's try this out real quick. Let me go ahead and download this to my actual DA30. Okay, back to my web browser. Look, there's the raw number here. So if I was to put in here, say, for instance, 12 milliamps, There it is. If I go back to my simulator, so that's showing 12. That really should show 32,767. Hold on a second here. Let me look at something here real quick, your team. Yep. I don't like that. So hold on here. Let me change this. Let me do something a little different here. Let me go ahead and right click on this guy and do copy. Right click and paste. Let's call this one AI1 underscore milliamp. Oops. There. All right. So that guy there, let me go back to this one. Let me get rid of this work I did here. I'm going to turn off the scaling. This one's got the scaling. Okay. So I'm going to take this guy and make it equal to this one by doing this little trick. On the left, I'll click on this one. I'll go to the right side, and I'm going to expand my analog inputs, and I'm going to grab this particular tag, and I'll drag it right there like that. So now let's try this out. Let's try this and see what this shows up. We should get, I don't know if I put that on the page. Hold on, you're not going to see that right. Yeah, that's not going to work right. Nope, hold on. Go back to here. This guy shouldn't have any more. Hold on, let me double click on this. That's the right one. Let me click here. Oh, I still have this formatting. Let me put this formatting, turn it off here. Now let's go back to here. There we go. That's what I want. Okay, let me put this on the screen here. So that'll show us the raw number. And let's go one step further since I'm playing with that one. Let's go back to data tags. Let's do the same thing for analog output. So let's go ahead and right click and copy my A01. Right click and paste. And I'll change this one to say AI1 underscore little m big A. And on the data tab for this, we're going to do scale to integer 0 to 32,767. We want this to display as 400 to 2000. And if I go to the format tab, hit the pick button here and do numeric. And I'll change it down here, slide down 2 digits before, 2 digits after. Oops. And then down here, I'll put little m big A for units. All right. And then this one, I want it to equal to this guy. So I'll click the data tab on the left, highlight that tag, click the data tab for that particular tag, this guy right here. You can always tell right here. I'll go over to the right side and I'm going to grab my analog output 1, put it right here. Boom, right there. Now let's go to display page. Let's put this guy on the page here to see what it shows. Let's save it. Let's download it. Let's see what it does here. See if it updates. All right. So I'm not putting anything right now. So if this number, I should have put a limit in, but oh well. If I put in something halfway between 0 to 32,767, that's 11.81. You can see over here, I'm not getting anything from my simulator. So if I go over to this guy and put in maybe 10,000, for instance, boom, come back to here, and I'm putting out 8.8 milliamps right now. If I go over to this guy and put it closer to, say, 32,000, I should get about 20 milliamps. Yep, there you go. So anyway, quick way to make the emulator. And I've done this in a number of projects which work out great because now I can use this for testing. Instead of having to jumper wires or so forth, I can use this quickly to test things that's talking to an E3 for another application. And you can use this with any Modbus master, this concept of building a slave that works, or a server in Crimson 3.2. So in this case, I'm using a DA30, which is mimicking the real E3 IO that I actually have plugged in this case. Anyway, if you want to copy this video, please send me an email. I'll share it with you. The important thing is the communications, the gateway blocks have got to be set up correctly with which way the traffic goes. Hey, thanks a lot, folks. Have a great day.